So you might want to jot the date down. Today is February 12th, 2021. And we're graphing quadratics. We want to start out with, first of all, just recognizing that standard form of a quadratic. We already know that. But the standard form is y equals x squared. Remember, it's ax squared plus bx plus c, okay? We talked about that before. We know that a, b, and c are coefficients of x squared, x, and then the constant. But also want us to understand, too, that that same thing could be written as a function. Remember, y and f of x is interchangeable. So you also might see it written this way. F of x equals ax squared plus bx plus c. Now, we've talked about that when graphed, quadratics create a shape that's really usable, actually. I mean, we see it in nature, we see it in sports, we see it in satellite dishes, we see it all over the place, and they create what we call a parabola. That's the name of that curved shape we're going to look at, so you might want to jot that word down. They create a parabola. In real words, that's just a U-shaped curve that either open up, looks like a U, so it opens up, or that U-shaped curve opens down like that. Some facts that we want to know is that if A is greater than 0, it will open up. In other words, if A is greater than 0, if it's positive, okay? If A is positive, it opens up. If A is less than 0, in other words, what I mean by that is if it's negative, A is negative, it'll open downward. That concept of opening up and down is pretty important because we need to know what it's going to look like. So a downward, if it opens downward, then it's going to look like that. So if A is positive, it opens up. If it's negative, it opens down. It's easy to recognize a quadratic and easy to recognize whether the shape will be like a U or an upside down U based simply on the sign that's on A. We'll look at some of those here in just a minute. There's other things we need to know, like the y-intercept.
I heard that since 8th grade. What is the y-intercept?
The y-intercept is the point where the parabola will cross the y-axis. And there's only one of those, okay? It's the point where the parabola crosses the y-axis, okay? And again, this point singular. And we remember from linear equation that means that x is equal to 0. There's no way it's going to be able to cross that y-axis unless x is 0. Here is an interesting thing. With quadratics, the y-intercept is where x is equal to 0. And if x is equal to 0, then the c term is actually the y-intercept. And it kind of makes sense if you think about it just for a moment, okay? If x is 0, in other words, there's no way it can cross that y-axis unless x is 0. If x is 0, when I put a 0 in for x, 0 squared is 0, 0 times a is still 0. It makes all that first term be 0, and it makes this second term be 0 too, because when I multiply 0 times b, I'm still going to get 0. So x has to be 0, so my y-intercept will always be the value for c in standard form. So I've just written that here, that the y-intercept is the point 0 and c. Again, we'll look throughout this lesson and throughout the next few days at how we find that. There's probably a new term here that you've never heard of called the axis of symmetry. I try to get your vocabulary down to just the words you need to understand and use. This is one we're going to use a lot. The axis of symmetry is a vertical line. In other words, it's an up and down line. And that line divides the parabola into two equal parts. Now, there's an equation for that. That axis of symmetry, that vertical line is going to be x equals some number, okay? Because it's just a straight up and down line on the x-axis, okay? And that some number we can find actually with a formula. It's the opposite of b, sounds a little bit like the quadratic equation, but it's not, over 2a. It looks like a piece of the quadratic equation, actually, just the front part of it. Negative b over 2a without the plus or minus the square root part. We can always find the axis of symmetry by taking the coefficient of b and reversing its sign and dividing it by 2 times the coefficient of x squared, or a. And again, we'll look at some examples of that. Finally, the vertex, okay, that's the turning point of the parabola. For example, if the parabola looks like this, the turning point is right there. That's the vertex. And it's a singular point. With the parabola. It's the turning point of the parabola. And we give it some specific names. We either call it the maximum, or the minimum. This would be a maximum because it goes that high and it stops. It doesn't get any higher. It doesn't get any bigger. But if the parabola was turned the other direction and it was upward, then it would be a minimum because it goes down to a low point and it doesn't go any lower than that. So based on the shape of the parabola, it tells us whether it's a maximum or minimum. So the way that we find the vertex is pretty simple. We have an x and a y. We have a point that has an x value and a y value. And for x, you need to substitute the axis of symmetry. Now, if you remember, we have a formula for the axis of symmetry. That is x equals negative b over 2a. So basically, whatever that value is, I'll plug into x. So that value is going to go in for x. Then I'll take the equation of the quadratic and I'll find y. And I'll have found the vertex. Remember, that's going to be a point with values x and y. I don't know what those numbers are, but I can find them pretty easily. Once I find that axis of symmetry, I'm just plugging it in for x and finding y. Last couple of things in your notes that I would like to remind you of is that anything we graph has a domain, which are the possible, what is a summary of all the x values? All possible x values. We've had that before. We've talked about domain. And the other thing we would like to remind you too is that it also has a range. And that's a summary of all possible y values. So when I talk about the domain, I'm saying, okay, what's the potential here? What does the x values look like? If I'm looking at the range, what do the y values look like? So we're going to take all that information and work to graph some quadratic equations. I want to look at a quadratic graph. This is really known as the parent function. So the simplest quadratic function is y equals x squared. What I want to do is I want to look at that and kind of come up with some information about that graph based on what we find. For example, if I asked you, what is the value of a? Well, the coefficient of x squared, in other words, the number in front of x squared is 1. There's not an x term, so b would be equal to 0, and there's not a plain constant out here. It's just x squared. It's not plus something x plus some number, so b and c are equal to 0. And typically the parent function is the simplest form of that quadratic. Now, a is positive, so this quadratic will open upward. It opens up. And the y-intercept then is, since c is 0, my y-intercept is equal to 0. In other words, it'll touch or cross the y-axis at 0. The other thing I want to look at is that axis of symmetry. So the axis of symmetry here is x will equal negative b. Well, what's b? b is 0 over 2 times a. Well, 0 over 2 times 1 is still 0. So my axis of symmetry will be x is equal to 0. To find the vertex, remember the vertex is going to be some kind of point. I know that it's my axis of symmetry, which was 0. And I plug that 0 in for x and I square it. Well, 0 squared is still 0. So when I go and I put in the y equals the 0 squared, when I go to square 0, it's still 0. So really very simply, the vertex is 0, 0. The other thing I would like to do is take that same quadratic and create a T-chart. So what I'm going to do in my T-chart is to take values of 2 and plug it in for x. So 2 squared is 4. 1 squared is 1. 0 squared is 0. Now when I put a negative 1 in here for x, a negative 1 squared, that's negative 1 times negative 1, that becomes a positive 1 again. And when I take a negative 2 plug in there, I square a negative 2, it's negative 2 times negative 2, that becomes a positive 4. So in this chart, I've got values for this graph. I already learned a lot about the graph just by breaking it down into the y-intercept and the axis of symmetry and all that kind of stuff. So let me just put that on a graph for you. Take that same information. Let's talk about how is that going to look on the graph. All right, so I've got a T-chart there, and I'm going to hand make this graph because I think it's actually a little simpler to see. And I would like for you just to sketch that graph on your paper as well. Remember, this is 0, 0, and I've got 1, 2, 3, 4, 5, 6, just like that. And then I've got positive 1, 2, 3, 4, 5, 6, 7, negative 1, 2, 3, 4, 5, and etc. And I'm going to take the values I found. For example, I'll start with the vertex. That's 0, 0. And then I want to take x is positive 1, y is positive 1, so that'd be that point right there. And x is positive 2, and y is 4, 1, 2, 3, 4. So I'm beginning to get the shape. Likewise, when I go negative 1, it's positive 1, so it's a mirror image in this direction, and then negative 2, positive 4 here. And when I go to graph it, that shape looks like that. And again, it's just a sketch. It's not perfect. I wished it were perfect. Your graphing calculator will graph it perfectly. But let me show you some points real quick. 0, 0 is the vertex. The axis of symmetry. Okay, now that happens to be also the y-axis in this particular problem. That slices that quadratic or that parabola in half. So that's the axis of symmetry. Notice because when I said y equals x squared, a is positive and it opens upward. That's easy to figure out just by looking at it. And it has a minimum. Minimum. I think I can spell minimum there, okay? It has a minimum because it goes down this far and stops. Two other things I want to look at is very simply that my domain is all reals. In other words, as it goes in both directions on the x-axis, it'll cover every value forever in the x-axis. But my range is a little different. It will never get lower than 0. So my range is y is greater than or equal to 0. So in other words, going this way, my range, all my y values will never get below 0 on the y-axis. So that's just the parent function. That's the parent function of y equals x squared. That's what it looks like on the graph.